Hi guys, today we are going to continue with problems and their solving. Now we start with the question number 12. Osmotic pressure pi is the extra pressure required to raise the chemical potential of the solvent in this solution to the value it has when it is pure. Please calculate osmotic pressure pi of seawater at 329 Kelvin. Seawater contains 32.8 grams of sodium chloride per liter. Before going into solving this question, we need to define what is osmotic pressure. Is a pure water here. Pure water. As you know, activity of pure water is 1. Here I'm going to put something else here. This is pure water, and this one is contains water, but impure water. Let's say sodium chloride solution. I don't mean that it is a contaminated solution. What I am saying is here, this water is purer than this water. So there is a distinction here between water, pure water, and impure water. Here is this is the pi, this is osmotic pressure. And let me write down here, the extra pressure required to raise the chemical potential of the solvent, here solvent is water, in the solution to the value it has when it is pure. So there is a desire for sodium chloride solution. There is a desire to become pure water. There is a potential difference between pure water and impure water. Due to this potential difference, we get a pressure. It is called pi. Here, this one is, and this is impermeable. This is the membrane. Make sure water goes inside the membrane and to increase the level of the water present in the impure water. And this belongs to pure water line, and this belongs to impure water line, as you see here. And there is a difference like pi. I'm going to sketch it for you. The pressure inside the membrane, let me express by chemical potential. This is the chemical potential of A, pure A, and this is the chemical potential of impure. Water is a solvent, and that can dissolve many salts, many compounds like sodium chloride, barium chloride, sodium sulfate, etc. And when water dissolves the sodium chloride, we get a solution. Okay, this is solvent and this one is solute, and they become to form a solution. Now it is no longer water, pure water, nor sodium chloride. This is a solution of water and sodium chloride. And now we call it here in this present question, impure water. I don't mean that this is contaminated water, dirty water, but it is impure. It is less pure than pure water. The pressure inside the membrane with the impure water is greater than the pressure on the side with the pure water. So pure water exerts pressure to impure water, and we get a pressure, we call it pi. As you see here, chemical potential of A impure water and the chemical potential in the pure state is equal to R gas constant times temperature times ln XA. And let's remember Rolle's law, mu A minus mu A standard RT minus 1xxb. Here, according to XA is equal to activity of A. Instead of activity, we could write down XA, and XA plus XB is equal to 1. Instead of XA, I could write down XB. Here, pure water in the water. Exert pressure here. Mu A minus mu A0 is equal to RT ln XB. Actually, RTXB. Why? If XB is too small, then ln 1 minus XB is equal to minus XB. Okay, then P minus P0 is called pi. This is osmotic pressure. Mu A minus mu A0 P plus pi osmotic pressure to pi VA. This is molar volume of A. In this present example, this is water times dP is equal to minus VA, molar volume of A, times pi. So mu A, the difference in chemical potential. While one side is pure water, other side is impure water. That is the reason there is a difference between two of them. Is equal to minus RT XB is equal to minus VA times pi. Here, pi is equal to RT XB and VA. As you see here. Let's go back to question here. The question asks us to calculate osmotic pressure of the seawater. This is actually easy to solve, but you need to understand the idea behind of the question. Here, and sodium chloride, 32.829 gram, 8.5 gram per mole, and water, 1 liter corresponds to 1 gram. This is 1 liter. And the molecular weight of water is 18, and this corresponds to 55.55. And when we do the calculation here, let me use the calculator here. Two point 1.1 and also 256 grams. And XP here 0.01 and this sodium chloride, sodium water is 0.99 and it's a mole fraction. And let me write down the formula, but here I'd like to mention that sodium dissolved in the solution dissociates into sodium ion plus chloride ion here. So we need to multiply by 2. Pi is equal to R times temperature times Xp, sodium chloride, times 2, this comes from here, divided by dA. Here, 8.314 times, it is room temperature, 329.2758 Kelvin, and the VA is 18 times 66 cubic meter times 0.01 times 2, and pi is equal to about 30 atm. So the osmotic pressure of the seawater is 30 atm. What does it mean? One side here, pure water, and this is the salty water. This is 0.01 and 0.99 X water, and this is X sodium chloride. And pure water exerts pressure to salty water or brine water, seawater, 30 atm. And we should know that the important thing I'd like to mention here, this is Gibbs free energy change here. This is delta G value, molar volume times pi. If one were exerted on the aqueous solution a pressure greater than the osmotic pressure, say 30 atm, when we apply 40 atm, which is greater than osmotic pressure of salty water, brine water, then what's going to happen here? Then what's going to happen, let me explain. Water from salty water goes to pure water, and in this case, this phenomenon called reverse osmosis, which is used to produce purified water. Normally, pure water exerts pressure, 30 atm pressure to salty water, but when we exceed this pressure, let's say apply 40 atm, and the purified water can be produced. The water from impure goes to pure water side, and in this way we can manufacture clean water, and this water contains no ions dissolved in it. When we add the specific ions to this water, then we can produce drinkable water, and this phenomenon called reverse osmosis. Water would be forced through the membrane from seawater to the side of pure water side, and this is called reverse osmosis, which is used to produce purified water.